Hey guys, today we are going to solve the problem merge intervals. In this problem, we are given an array of intervals where each interval is a list of two integers, start and end. And we are asked to return all of the to merge all of the overlapping intervals and return the result. So when are two intervals overlapping? So let's say we have intervals AB and CD. These intervals overlap if we have two things. One, A is smaller than C, and B is bigger than C, or equal. What does that mean? Let's look at the drawing. So we want, if we have this interval is AB and this one is CD, we want the first interval to begin before the second interval begins, but we want it to end after the second interval begins. So it means that they overlap. Now that we know that, we can see that we really care that A will be smaller than C, which kind of hints that we would like to have the interval sorted, and we also get the interval sorted, at least at the examples, which also hints that we would like to do that, and this is a common theme in interval problems. Okay, so let's say that we sorted the input by the start value. So what we could do now? Let's have a look at the algorithm. As we said, first of all, we are going to sort the intervals by their start position. So in this case, in this example, we are already given sorted input. Now what we are going to do is we are going to initialize a result array, and it's going to hold the first interval. Now in the future, we might merge this interval with some other intervals, and then the result array is going to be updated. Or this interval is not going to merge with anything, and we are not going to touch it. So now we move to the next interval. This is the candidate to merge with the previous one. In this case, we can see that they do merge, and we already explained how we can know the boundaries of the new interval. So we are going to take the start index of the start position of the first interval. So 1 is going to stay, and we are going to take the maximum between the end position of the two intervals. The reason why we have to take the maximum is there is one more case for the two intervals on how they can look. They can look like this, but it could also be that this interval would end after the next one. So we are going to take the maximum. In this case, it's just going to be 6. So we update the 3 to 6. Now we consider the next interval. In this case, we can see that they don't overlap. So we can add it to our result. Now when we consider the last interval, with which intervals that we've previously seen could this interval merge? It could be either this interval or this interval. But my argument is that it is enough to check the last interval, and we don't have to look at any previous ones. Why is that? Well, it's pretty clear that the start value of all of the intervals before the current interval we are looking at is going to be smaller than the start value of the current interval. So the start value of any interval here is going to be smaller than this one. This is because we sorted the array by the start values. So one of the two conditions, if we have two intervals, A, B, and C, D, as we said, one of the two conditions in order for those intervals to overlap is A has to be smaller or equal to C. So it doesn't matter which interval of the previous one we are going to choose, this condition already satisfies. So the other condition we need is we want B to be bigger or equal to C. So my argument is the last interval is always going to be the best candidate. That is because if this interval is CD and this one is AB, or any interval that comes before this, the last one is going to be, let's say, AB, then we know for sure that B is smaller than C. Because if they were equal or if B was bigger, then we would merge these intervals. So B is smaller than C, but C is always going to be smaller than D because the start value is going to be smaller than the end value or equal. I'm not sure how the question said. Maybe the question said that we can have intervals like 1, 1 or something like that, but it doesn't matter. So the only interval we have to consider when looking at a current interval is the last one. So in this case, we have 15 and 18, and it's enough to look at the previous interval, in this case 8, 10. We can see that they do not overlap, so we could simply add this interval to our result, and with that we finish iterating over the array, and that is going to be our result, which is correct. What is the complexity of this solution? So the first thing we do is we sort the array. So that's going to cost us n log n. And then we simply iterate over all of the intervals and we begin merging them. So that's just going to cost us O of n. So total is going to be big O of n log n. And the space complexity is going to be constant if you don't count the result array, and if you do count it, then it's going to be linear. So first of all, we are going to take care of one edge case where we got no intervals in the input. So if we got no intervals and we are going to merge them, then of course we are going to end up with no intervals. The next thing we are going to do is we are going to sort the intervals. So when you sort a tuple, it's by default going to sort first by the first element in the tuple. So if we have start and end, it's going to first sort by start, and if we have a tiebreaker, it's going to sort by the end. So this is going to do the work. We could also tell it to only sort by the first element, but there's no reason to do that. Next thing we are going to do is we have to remember that we are starting with the first interval in our result. Then we want to loop over all of the other ones and check which ones are overlapping. So as we said, we only need to consider the last interval. And if the last interval is overlapping with the current one, and the reason this is enough is because we are iterating through the intervals in sorted order. So we know the last interval, if we have two intervals AB and CD, then last interval is AB, then A is always going to be smaller than C. So we already have A smaller than C, so we only need that B will be bigger than C. So that's enough to check that. If that's the case, then we want to merge the intervals. If not, then we want to append the current interval to our result. Of course, after we append it, in the next iteration, last interval is going to be this one, and we might, in the future, merge it with some other intervals. Once we are done with this loop, then we can just return our result. Yeah, good.